Charges by Karthik Chilukapati. So the purpose of this lab is that we are trying to find the charge on pieces of tape, which is almost the same as lab 1. The only difference is that in this lab we are looking at a line charge rather than a singular point charge. Physics principles that we're going to use are that the electric field is equal to K times Q1 times R hat over R squared. Our electric force is equal to Q2 times the electric field, and our gravitational force is equal to mg. Previewing the results, when we just plugged in our information for the code, we got that the electric force was 4.6 times 10 to the negative 4th newtons. Our gravitational force was 1.86 times 10 to the negative 3rd newtons. But when we were trying to find what charge would make these two values equal to make the sum of the forces 0, we found that the charge on each tape was 2.6 times 10 to the negative 8 coulombs. Initial conditions for this lab, our system was tape B, surroundings tape A, basically the same as lab 1. Initial conditions, our mass was 1.7 times 10 to the negative 4th kilograms for the tape. Its length was 0.2 meters and its width was 0.02 meters. Here are some diagrams just to show our basic setup, which is the same as lab 1. Experimental data was retrieved from our lab 1 experimental data. So our tape charge that we found there through GlowScript was 1.32 times 10 to the negative 8 coulombs. Missing electrons 8.25 times 10 to the 10th, and our ratio of electrons to atoms was about 4.85 times 10 to the 6th. Nothing new, just same data. Here's our computational data for this lab. Over here we brought the mass of the tape, and we have our Q here, which we were altering to find what would make our gravitational and electric forces equal. Over here we just messed with the scales a little bit to fix our arrows and make them more visible. And here we have our arrows representing our electric force and gravitational force. And here's the math we did to calculate these values. So discussion for this, after trial and error by altering the Q value in our code, we eventually found that to make the electric force and the gravitational force equal, our charge had to be 2.6456 times 10 to the negative 8 coulombs. This made our electric force equal to about 1.86392 times 10 to the negative 3rd newtons, and our gravitational force equaling 1.8639 times 10 to the negative 3rd newtons. So they're both basically the same thing. Errors are the same as in lab 1 because we're using that data to create a model in this lab. We could have those same errors that the tapes were possibly, some of the charge was possibly gone to our hand, or we didn't measure the length correctly of our tape and such. What if and why questions. So it says, what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So our point charge model was 1.32 times 10 to the negative 8 coulombs, and our line charge was 2.65 times 10 to the negative 8 coulombs. Here we can see that if we calculate the percent difference, it's about 100.46% difference, which is pretty significant. And those are our comparison values. But why do these estimates differ? Which value is more likely to be closer to the real value, and why? So these estimates differ because both of these models choose a different way of calculating it. Our line charge is mostly more accurate because its way of calculating it, we have more steps in our calculation, so it could be producing more accurate results.